Section 4-3 is a new section called Relations. So when we talk about relations, we're talking about a pairing of two numbers. And we can represent this by a lot of different means. The first is an ordered pair, and I know you've seen these. So one relation could be the grouping of the numbers 3 and 1, 2 paired with -2, -1 paired with 4, and 2 paired with 1. So we've simply paired two numbers together. Another way to represent this is in an XY table. So we put the ordered pairs listed in table form. Still the same relation. Okay. Another means is by a graph, and we've done this recently. So 3, 1, 2, -2, -1, 4, and 2, 1. So that's a graphing representation of our same set of numbered pairs. The last is a mapping, where we take our x values, and list them, 3, 2, and -1. I don't need to list the 2 twice because I already have it. And I put those in a group. And then I put my y values in a group, 1, -2, and 4. And then I show the pairing, 3 pairs with 1, 2 pairs with -2, -1 pairs with 4, and then 2 also pairs with 1. So those are the ways that we can represent these pairs of numbers. We can also then talk about domain and range. Remember, domain is the set of x values for a particular situation. In this case, my domain is 3, 2, and -1. Again, a number that repeats in the domain I don't need to list twice. And my range, which goes with the y values, I'm going to just write over here x values. X comes first. Oh goodness. And the range is my y values. So the y values in this particular relation are 1, -2, and 4. So that's all a relation is. It's just a way of pairing up numbers one with another so that we can have an organized expression or an organized way of representing the pairs that go together. So I'm going to give you a graph. So obviously I'm doing the first of the 4 methods, actually the last one, the graphing method. And I'm going to graph these values. I'm not putting the ordered pairs by them because I want you to get that yourself. So I want you to take this relation, which I've plotted on a graph form, and I want you to do it as an ordered pair, as a table, and as a mapping. So pause the video for a minute and do that. Okay, we should have our ordered pairs should be -2, 2, -1, 1, -1, -1, 1, 1, and 2, -1. And they don't have to be in the same order that I did them in. Your table should look something like this. -2, 2, -1, 1. Again, if you chose a different order, yours is going to look a little different. And our mapping should have the numbers -2, -1, 1, and 2 in the x map, and 2, 1, and -1 in the y. -2 pairs with 2, -1 pairs with 1. It also pairs with -1. 1 pairs with 1, and 2 pairs with -1. So that should be what you came up with for your mappings. The last thing we're going to look at in this section is inverse relations. And inverse relations are obtained by switching the coordinates in each ordered pair. So if I give you a relation that's represented by the ordered pairs -3, 1, 2, 5, -1, 4, and -2, 3, the inverse of this relation is represented by 1, -3. You see I've just switched the x and the y from the first order pair to look like this. The next ordered pair, if I switch it, I get 5, 2. If I switch the third ordered pair, I get 4, negative 1. And switching the last ordered pair gives me 3, negative 2. Okay? Now, if I plot this ordered pair, or this relation, negative 3, 1, 2, 5, negative 1, 4, and negative 2, 3. Let me find it. There it is. If I want to plot the inverse relation, I can do that. So the inverse would be 1, negative 3, 5, 2, 4, negative 1, and 3, negative 2. And you can see that they have sort of flip-flopped over this central line. We'll talk more about that later. But each original pair ends up being almost, well, if I'd done my plots better, equidistant across this central diagonal line. Okay, and that's just something to keep in mind for the future. We'll talk about that more as we do more with inverse relations. And that's it for this particular video.